Well, I think it's probably about the time I'm supposed to start, so I'm going to start. So my name's Martin Woolley. Thanks a lot for coming. Really nice to see you all here. I work for a company called the Bluetooth Special Interest Group, who you may or may not have heard of, but we are the standards body for Bluetooth technology. So we are responsible for the 3,000-page specification, and manufacturers then use that spec to implement Bluetooth, and hopefully then we get interoperability. So that's the essence of what the Bluetooth SIG is about. Now, we are going through interesting times. That's not a political statement. I'm going to stick to the technology here. I'm going to try anyway, try really hard. But the Internet of Things is kind of upon us. It's emerging. It's a real thing. It's not marketing hype. We know it's real. And it's interesting to reflect that in the 1990s, there were 1 billion devices connected to the Internet, which is a big number in itself. But only 10 years later, thanks largely to the rise of the smartphone, we had 2 billion devices connected to the Internet in the 2000s. So it's a pretty big number. But there's a forecast from a research company called ABI that says that by 2021, there will be 48 billion devices connected to the Internet, which is fairly phenomenal and only a few years away. And for us, particularly interesting, 30% of those devices will have Bluetooth technology. Now, last year alone, over 3 billion devices with Bluetooth technology were shipped. That's in 1 year. So it's a really, really ubiquitous wireless communications technology. It's in pretty much every smartphone. I think 3 years ago when I started work for the SIG, I was saying 96% of smartphones had Bluetooth in them because that was the number I was given from some research company. I think it's a bigger number now. You can pretty much count on Bluetooth Low Energy specifically being in smartphones. So it matters to Android developers. It's there for you to exploit in all sorts of interesting ways. Now, one of the places where Bluetooth has really begun to take off, outside of the usual areas like audio and health and fitness devices and medical devices and smart buildings and that kind of thing, concerns things called beacons, which is what I'm going to be talking about here. So beacons, we'll talk about what they do, how they work, how you use them as an Android developer in a moment. But again, numbers I kind of quite like because they help me decide whether I should pay attention to things or not bother. The last few years, I would say beacons have been going through early pilot stages. Maybe 2-3 years ago, a small number of companies were piloting, experimenting with this new technological device, learning from the experience and so on. Now we're seeing real serious rollouts taking place, with beacons being deployed in shopping malls and airports and museums and art galleries and so on. Google have got involved and are doing some very, very interesting things I'll mention in passing later on. And there's a session tomorrow you should definitely go to about the nearby APIs from Google as well. But it's the forecast I want to draw your attention to here. 2021 again, this magic year that we seem to select for forecasts. It's forecast that in that year alone, so these are not cumulative numbers, in this year alone, over 500 million Bluetooth beacons will be deployed. That's a massive number. So these things are going to be everywhere and consequently need to be part of your thinking as an Android developer. These things are in the environment, what do I do with them to enhance my application? So, what are beacons about? Essentially, they're small devices that let you, through the magic of proximity, determine the location that a user is currently in, find out something about the environment and share that knowledge with the user, take some form of action based on proximity data that you have, and increasingly to interact with that physical environment. And this is part of the whole Google Physical Web idea. Who's heard of the Physical Web project? Well done. Excellent. Brian's from Google. I'd have been upset if he'd had his hand down at that point. And all this stuff, including the physical web, is very much centered around Bluetooth beacon technology. So, I'm going to kick off with a high-risk live demonstration, which, like all high-risk live demonstrations, might go horribly wrong, but I'm going to do it just to give you a kind of good mental picture of what's involved in beacon use from an Android application. Bear with me whilst I try and... I'm going to actually escape from PowerPoint because it goes wonky sometimes. Let me just try and find the right screen here. There it is. So I've got a tablet plugged in. I'm down here. I'm just going to fire up this application, which has the world's worst, and you can't see it, so hang on a moment, the world's worst user interface. I take full credit for this awful user interface. It's my finest Android development work. There it is. You like it? This is how not to design user interfaces. So what I need from you now, so this is audience participation, is I need you to harness the power of your imagination. And what I want you to do is consider me being in a museum. I've got my smartphone or tablet in my hand. I have to leave it over there because it's plugged in, but we're going to pretend you can do this. You can do this, okay? And I'm going to be walking through the museum. Now, the museum has a number of remarkable exhibits, and I've brought some of them with me. Here's a real dinosaur. It's real. And placed right next to it is a device which is acting as a Bluetooth beacon. I'm going to tell you how these things work and what's going on later on, once we've seen what they can do. And over here, in the next room of my museum, I have a valuable and very rare fossil. Or is it just a rock? You'll never know. It could be a fossil. And next to it, we have another device acting as a Bluetooth beacon. And then over here, I have a third beacon, which is next to nothing, but I'm going to pretend it's next to a valuable starfish. So, the way it works is I walk into the room, I've got my device in my hand, and I come into range of the Bluetooth beacon, which is broadcasting a unique ID. And as a consequence of my application, receiving that broadcast message, looking at the ID, it knows I'm near the dinosaur. So it tells me some essential information about the dinosaur, like it's scary, it's got big teeth, and I'm like, oh, didn't know that. So my experience is being enhanced purely by this proximity technology. It's very cool. So I'm kind of cheating with my demo a little bit up here, okay? I'm switching things on and off, which I wouldn't normally do. So I walk into the next room, and we encounter the next beacon broadcasting. We leave the other one behind. Its signal strength is lower, so I know which one's the closest, which one is the nearest. And with a bit of luck, I'm just going to kill some time here by grouping this. There we go. Yes, I was getting nervous then, you could tell. So my application responds to the fact there's a new beacon there. In actual fact, the delay, which is something I'm meaning to change, is quite deliberate. I might try and explain to you why I did that later on. Signal strength fluctuates, okay? It could be I just walked behind a pillar, so you don't want to react too quickly, is kind of what's going on there. So, and then finally I look into the next room, and another beacon is there, and you never know if I talk for long enough with my fuzzy logic thing that's going, there we go, we get the seahorse thing. So I walk through the museum, I'm being informed as I go, I'm having to do nothing other than walk through a physical environment for this to happen. I'm not using QR codes, I'm not having to interact in a physical way. It's pretty much like magic. So, that's what beacons look like. Let's go back to the slides and continue. So, beacons take two broad forms, okay? There are beacons that you can buy from a supplier, and they come in a box and it says beacon on it. The point being that these are devices that are designed specifically and exclusively to do this job. And there's some, okay? They're all about this big and they're different colours and stuff, but they all do fundamentally the same thing. The one at the top I've chosen to highlight because I really like the fact that it reminds us of one of the key strengths of Bluetooth Low Energy. That is, it uses hardly any power at all. It's really power efficient. Because that device, which I've actually lost, but that's another story, is about that long, that high, and it has the world's smallest solar panel points. So it has no battery, no other power source, and it generates enough power for it to work inside buildings with ambient light. Very amazing. So not only can it function, but it's also able to communicate, just using solar power. So the lower energy capabilities of Bluetooth are feeding into a whole other area of research called energy harvesting. As we get into the Internet of Things, we're dealing with very small devices, very constrained, like you've never seen before, never mind smartphones. And those are supercomputers, we're talking sensors, tiny things that have to be installed in very difficult to get to places, so they need a power source that will last for years and years and years. Moving on. So those are the devices that you can buy from a shop, a beacon shop, and they're called beacons. But beacon technology can be embedded in other devices as well. And I've had meetings with companies that make power tools, like drills and things. They're embedding beacon technology inside these products because it means you can't lose them again. Okay? As long as the beacon is broadcasting, you can find that device. Think about really large construction projects and contractors leaving things and forgetting where they are. So beacon technology is going to appear in all sorts of things, and that's not included in the data I gave you earlier on, 500 million in 1 year alone, in only a few years from now. The device at the bottom there, the stuff at the top is kind of just some examples of things I think we'll see, and I've had conversations about power tools. The thing at the bottom, that's a real product. So that's a power outlet for the US market. So, you plug things in, they get power, they do what they do. But it has a beacon inside it, so it means that the emergency services, for example, will find it much easier to find people who need help in very large buildings, because there are beacons everywhere, and they have an app on their phone, so we know where they are. So, let's find out how these things work, and move on to look at what APIs you have available to you. I don't know if this will work. There's an animation coming. Let's see if it works. No, you can't see it. See on my screen it looks glorious. I need to change the colour. So, Bluetooth devices can be used in one of two ways. And one is connection oriented. They connect to each other, they have a conversation and interact in some way. Or they can be used in a connectionless way. And the connectionless way leverages a capability of Bluetooth called advertising. And advertising is the technical term, but it's basically a broadcast technology. So the device can be advertising or broadcasting some data. Any other Bluetooth device in the environment that's in range, that's able to receive packets, can receive those packets and act upon them or ignore them. It's choice. So no connections involved at all. Therefore, you could have thousands of devices all making use of the same data broadcast by an advertising Bluetooth device. And advertising is the capability that beacons are built upon. That's the fundamental technical capability of Bluetooth that beacons are leveraging. Now, I could show you what it actually looks like in practice, or I could try. Shall we try this? I don't think this is going to work very well because my screen refresh rate isn't quite good enough. But let's see if I can do this. Hang on a moment. Oh yeah, there it is. Right, so I've also got a phone plugged in here. So a different device, and if I can remember where it is, it's not on that one. Let's go back to this one. This is when I've kind of completely messed things up here, but demos, there we go. ADV scanner, start scanning. You won't see the detail, but you will see just how much data is whizzing by. Every one of those blocks is an advertising packet. But there are lots of Bluetooth devices around here. There are beacons here, out in the exhibition area. So loads of stuff going on there. Let's kill that off. There we go. So back to the wonders of PowerPoint. So you can imagine these things filling the air. They're everywhere. They're being broadcast very, very quickly. So beacons are an application of Bluetooth technology. So the Bluetooth special interest group, we don't specify how beacons work in terms of the application itself, just the underlying communications technology is our responsibility. So there have emerged, I would say, 3 key types of beacon, of which 2 are very much predominant players. So the original one was iBeacon, you've probably heard of that, that was from Apple. Then came AltBeacon, which is like an open source version of iBeacon without some trademark restrictions or something like that, some lawyer stuff. And then more recently, but still a couple of years ago at least, 3 years ago, thank you, Eddystone came along from Google, and Eddystone is what I'm going to talk about most here because I think it's the most interesting and the most versatile. So let's dig into what's going on here. So, packets are being broadcast through the air every 15 milliseconds or 100 milliseconds or something like this. The beacon developer will decide. What we are working with are small packets. Advertising packets are 37 bytes long, maximum. Give or take something I'll tell you later on. This has just changed. But let's just say for now, 37 bytes. And 6 of those bytes are the address of the device that is broadcasting the data. So we lose that, we can't use that. We get 31 octets or bytes to play with. And into that space we can put some data, which has to be in a specific form. They're called AD types. They have a length, they have a type, and they have a value. And those types are defined by the Bluetooth Special Interest Group. It's on our website, there's a list, and that defines what you're allowed to put into these advertising packets. That's quite possibly what I was meant to say. Oops. Yeah, there. So, that's what we're working with. Not a huge amount we can get in there. If we look at specifically how Eddystone does it, iBeacon and Eddystone work quite differently actually. What is their frame format? What does their data look like? It looks like this. I hope you guys can see okay at the back, but there are two fields used by Eddystone. I might try this. Does that help? That might help. There you go. So we have a field, we have a concept of a service, and Eddystone regards itself as providing a service. So it's allocated to itself a unique ID, and that unique ID is broadcast in one of the fields. The ID is FEAA, it's a hex number. That means Eddystone. And then the advertising packet data types allow you to associate some data with a service, and that's what the next field is for. So then the Eddystone data itself goes there. So this is being broadcast. Now if we look inside the Eddystone data packet, then we start to see what's really there and get some hints as to what we can do. iBeacon has one frame type, and it allows you to broadcast a unique ID, which an application then associates with a thing or a place or a person. It's an ID, you do a lookup in a database or to some cloud server. That's how it works, it's very simple. Eddystone, they're thinking ahead, and they're already four subframe types, if you like. The first is a unique ID, just like the iBeacon idea that I just described. The second is a URL, so we can now broadcast URLs in a special compressed format, which is in the Eddystone spec. We can broadcast telemetry data, so data about the beacon itself or the machine it's embedded in. And EID, it's the most recently added frame type. This is a way of securing the IDs that you're using so that other applications can't jump on and use your beacon infrastructure that you've just spent lots of money rolling out. It's ephemeral ID it stands for, so there's some cryptography goes on in that frame type as well. So let's talk about Android and beacons then. So hopefully you can see the essence of what's going on here. Bluetooth has this advertising capability, it's a broadcast capability. Eddystone lets us broadcast things like unique IDs and URLs. An application on a smartphone can certainly receive these packets, look at the UID and conclude they must be near to the dinosaur, the plastic dinosaur, that world-renowned museum exhibit. So what do you guys do as an Android developer? You have choices. There are APIs out there from third parties, but I'm going to look at the raw Android APIs. You're going to be doing essentially two things. One is called scanning, and that means switching the Bluetooth radio on so that you can receive packets, filter them, extract the ones you want, take some form of action, that's scanning. You're probably also going to do some form of distance estimation, because one of the other things we can do with Bluetooth beacons is figure out roughly how far away from that beacon, that known specific geographic location, the user is. You might be thinking, I use GPS for that, by the way. GPS is not going to work indoors or underground or in huge shopping malls and places like that. So one of the great things about beacons is that they're very good for indoor location finding. So using that ID to figure out something about the location of the thing and distance estimation are two primary things you're going to find yourself doing as an Android beacon developer or user of beacons. So those are some classes, and I've kind of very, very cleverly used colour to separate them here into blocks. And at the top there in the darker blue we have classes involved in getting started. What you want is an instance of Bluetooth LE scanner. So you have to ask Bluetooth Manager for an instance of the Bluetooth adapter, and it will give you the Bluetooth LE scanner. It's like one line of code, bang, I've got a Bluetooth LE scanner object I can now work with. You then configure the Bluetooth LE scanner in a number of ways. You can tell it things like how aggressively you want it to scan. I'll talk more about that in a moment, but you have a trade-off to think about, which is about battery versus user experience. I'll talk a bit more about that in a second. You can also do things like specify filters. Okay? Only tell me if you encounter Bluetooth beacon packets that contain this kind of information. I don't care about the rest. Don't burden my application with packets that are irrelevant. And some smartphones have the ability to apply these filters in hardware. So it can be very, very efficient. Not true in all phones, but certainly in some of the newer ones. Over on the left there, we have scan callbacks. And the final thing that your Bluetooth Italy scanner needs is something to tell that it's encountered another device. So your scan callback object is it's actually an interface you implement, and one of its methods will get called whenever there's something relevant to tell it. Here's a packet describing a device that's advertising that meets your filtering requirements. So that's how you find out what is out there in the real world. And you find out about the device that's issuing the broadcast message, the advertising packet, and you get what we call the RSSI. Who's heard of the RSSI? Who knows what that is? Roughly 3/8 of you. I'm lying. Maybe half, I don't know. Got bored of saying half. So roughly half of you. So it's the received signal strength indicator. So it's the strength of the signal, the Bluetooth signal, its radio, as measured by the receiving device, in other words, your phone. So you get that as well, and you can make use of that, and I'll come back to that in a moment. So, top tip. You as mobile developers should, of course, live and breathe this anyway. Be nice to your batteries, always been a mantra of mobile developments from, the beginnings of time, or maybe a little later than that. The same is true here as well. So Bluetooth Low Energy is the most uber efficient communications technology around, but you can still be mean to it, you can still drive it very hard and use more battery than you would have wanted to in the first place, had you actually thought about it. So there's a couple of variables you'll be thinking about, and Android kind of packages those up into some simple constants that you can specify in the configuration stage that we just heard about. You can say, scan very aggressively so that I detect packets very, very quickly so I can tell the user right now that they're near a beacon. Or you can say, scan less aggressively, because I know they're walking into an enormous room. I don't have to tell them the second they step through the door. I can tell them 3 seconds later that there's an enormous dinosaur right in front of them if they haven't noticed it already, right? So those are the sort of choices you make. And less aggressive scanning, much less battery use. Aggressive scanning, you're going to use your battery. It's very simple. So those are the sort of variables that are available to you, albeit Android kind of packages them up, so you don't have to worry about the numbers. But basically you have scanning interval, which is how often to scan, and scanning window, this is the terminology, which is how long you're going to scan for. And obviously if you're not scanning, you're potentially missing advertising packets. If you are scanning, you're going to receive them. So you have to think about that. Here's some code. Can you see us at the back okay? Can you read it? Shall I test you? No, I'm not going to do that. So, just an example of kicking off scanning from an Android application. So up here, and I'm pointing, let's see if this works. There you go, see that? You can't see that. I can see things you can't see, this is weird. So I'm calling get Bluetooth Italy scanner on my Bluetooth adapter, so that gives me that object that I needed to obtain an instance of. Then there's some stuff to do with setting up the data that describes filters. Now in this case, I actually am looking only for AltBeacon beacons. Remember that other type, the one that was like an open source iBeacon? So they use advertising packets a little differently to Eddystone. Different field is used for the advertising data. So I'm saying, only give me advertising packets where the manufacturer data field, that's the name of the field, contains a certain value, and that value is the hex value BEAC, which very cheaply spells beak, doesn't it? But it's a hex number. And this is the value that the AltBeacon people chose to use as the identifier for their beacon types, beak. Well, I thought it was good. You've got to like it when people put jokes into technical things. There should be more of it. It's a good thing. I then created scan filter objects, and the scan filter and scan settings objects both have builders attached to them, so you know the patterns, quite common in Android, so you use that to build your scan settings in your scan builder. And you can see here I'm using a constant called scan mode low latency. So these are figurative constants defined for you in the API, and scan mode low latency, despite everything I just said to you, means scan really aggressively. Because I want to know the second that the user walks into that room. Okay, so I'm saying, I don't care about the battery. I'm going to scan very aggressively. It's all good. And the final thing, so I didn't mention there, if you look at start scan at the bottom there, so I specify my filters, my settings, and a reference to callback objects, which is what the next slide is all about. So I've instantiated, I'm implementing an interface here, and I've got one method I care about, which is on-scan result. Now, what we get is, the thing we really care about is a scan record, okay, which is part of the scan result, and that's really the byte array containing the advertising data. Now, luckily, there are lots of nice helper methods, get this, get that, so you don't have to start parsing AD types from the raw byte array. You can if you're that way inclined, you enjoy that kind of thing. Takes all sorts, but you don't have to. So, in fact, that's exactly what I'm doing there. See, told you, it takes all sorts. I'm doing my own parsing for reasons which I really can't remember, but there are some nice helper methods, so you don't really need to do that. Possibly I wrote this code a long time ago. I will draw your attention to that method though, get RSSI. So one of the things I'm doing here, I've got my packet, so I know what's inside it, but I've also got the signal strength. So now here's what you can do. You can do something called a path loss calculation. So this is kind of black magic, almost engineering. It's about estimating distance. And you're working with two pieces of data, something I actually forgot to tell you earlier on. Both iBeacon, or all of iBeacon, AltBeacon and Eddystone include within their packets something called TX power value, and it's a reference value. So for Eddystone, correct me if I get this wrong, because I get the two mixed up, Eddystone is a number that tells you what the transmitted power is when measured 0 meters from the beacon. I think with iBeacon, the number represents the power that you would measure if you measured it 1 meter away from the beacon. Either way, it's like a known quantity. If you're this far from the beacon, this is what the signal strength should be. So if you're further away, and hey, here's the received signal strength indicator, you can compare those two numbers, do this path loss calculation thing, which by the way is in Wikipedia, if you want to look it up. It's not complicated. And the answer is an estimate of distance. It's just an estimate. It's useful. There's some very good applications out there. I was told today that IKEA in Sweden have a great application that uses beacons in their enormous indoor shopping things that they have. I want to say something negative about shopping, but I'm stopping myself at this point. So you can get very, very good results using that approach. And you can do triangulation and stuff with multiple beacons to get more accurate answers. So those are the kinds of things we do. A couple of issues for you then. Now this stuff I just talked about actually, ahead of myself. I'm going to get good at this. It's recommended that you calibrate your beacons in situ. In other words, in the environment that you're deploying them in. Because the environment will make a difference. If there are pillars in the environment and person has pillar between them and beacon, the signal strength measured by your phone will be lower. Things like that will happen. If there are lots of people in the environment, that will affect signal strength measurements as well. And so what I half described earlier about my application, the way it seems to take like a million years to tell me and buy the dinosaur, it feels like a million years up here, is that I'm deliberately not switching to the next beacon immediately. I'm actually doing some distance estimation in my code, and it's quite happy for there to be multiple beacons all broadcasting at the same time. What it tries to do is show the user information about the exhibits next to the beacon that we seem to be nearest to. That seems to be a sensible way of doing it. Now, if the user walks temporarily behind a pillar, at the moment that I scan, maybe I miss some advertising packets from one of those beacons. So I could conclude, oh, it's out of range, it's gone. I'll show the user the other exhibit now. But in fact, maybe that is a very temporary issue. So these are the things you need to think about when you get smarter at doing this. Did I just say I was smart? I didn't mean to do that. When you're more experienced, yeah, these are the kinds of things you try and do in the real world. So some kind of, I have some kind of expiry timer going in there, which governs the point in time where I conclude the beacon is now out of range. So I hang on to them for a little while. Another thing to think about, it's kind of obvious in a way, but you have two broad choices, and you could do both. You could respond to encountering a beacon with something that's interactive. You just saw me do it with the really interesting dinosaur information. Okay, it's interactive, it's useful, enriches my experience. You could, separately or in addition, do something which is not interactive, behind the scenes. Maybe you're actually doing some stuff in the cloud as a consequence of things that are happening out here. Now, beacons themselves are one way. Beacons can't track anything. Okay? They're just broadcasting. They don't receive any data. If you're concerned about privacy, which you should be, beacons don't track people. But smartphone applications could. So in the world of retail, a sector about which I know nothing, but I'm told they're very interested to know where you go in their big stores. Because sometimes people aren't buying stuff because they just don't go to that area of the store because the layout is bad or something like this. I can't tell you any more about that subject. So they really want to know where you're going in the store. So some of the time, it might be the case that the application you install, the loyalty application you install for the store, which gives you special offers, which says, hey, we've got some cheap tennis rackets because we know you like tennis and you just walked into the sporting goods department. It pops up on your phone and you think, oh great, I get a cheap tennis racket today, I'm so excited. Probably the payoff is that they're looking to figure out more about how to optimize their store. So you could do stuff in the background. I would say be very careful with privacy there. Maybe there are legal requirements in your country, and we have people from lots of countries here. I don't know. Something else I really like. So, wearable technology, another really big area for Bluetooth, because all these smartphones and fitness trackers, Fitbits and stuff like this, they all use Bluetooth Low Energy. All of them. They all. Someone's going to say, I've got one that doesn't. It's a Pebble from 1990 something or other. Don't know. Most of them use Bluetooth Low Energy. And one of the sort of fundamental premises of the smartwatch is just convenience. You're not pulling your phone out of your pockets all the time, you're just glancing at your wrist. And if you wear a smartwatch, who wears a smartwatch? Oh, again, 3/8 or thereabouts. Then you'll know what that's like. I happen to think that, I don't know if this is going to work, let's just try this. Here we go. So a bit of a video here. I mean, I'll talk whilst it's playing. I think wearables like smartwatches and beacons are a really good partnership because one of the problems for beacon application developers is this. You really don't want to bug the user too often. If you start bugging them about special offers and things too frequently, things they don't care about, they're just going to uninstall your application. Users are annoying like that. They've figured out how to uninstall applications. And it's very easily done, of course. So you need to be very careful that you don't exceed whatever their tolerance level is. And there are two ways of doing that. One is about being really careful and clever in terms of what things you think will be genuine interest to them. That's about knowing your customer. And the other is to make it more convenient by supporting things like convenience-enhancing devices like smartwatches. So I think the two go together really well. And you can do it in two ways. Who's done any kind of Android smartwatch development? Less than 3/8. Possibly 3 actually there. So with beacons you can do it in two ways. You can use something called extended notifications, which means no code on the watch at all. You're just leveraging the notifications API, and you can even make it interactive, which was one of the things you saw there whilst I was talking. Alternatively, you put some code on the watch itself, so you've got complete control over the UI, and again it's an interactive two-way relationship with Bluetooth Low Energy forming the link between watch and phone. I think it's a really good combination. So, what about beacons? Well, you could go to your beacon shop and buy one. You're going to need one to test with, that's for sure. Or alternatively, you could make one. Now, there are kind of two types of Bluetooth Low Energy device. There are those that are able to advertise, and they're called peripherals, technically. And there are those that are able to scan, and they have the strange name of central devices, central mode devices. And some of them can do both. So my phone can be central mode and a peripheral device as well. Beacons require the peripheral capability. They need to be able to advertise. So pretty much any device with a Bluetooth Low Energy stack on it that's able to advertise, you can turn it into a beacon. You just program it to advertise the right type of content in the right format. So things like, who's heard of the BBC microbit? There's all questions of this guy. I don't like this. I'm going to mark it down. A few of you have heard of the microbit. So this is the thing, a million of them went into schools in the UK last year, and it's to help kids learn to program and make things in the Internet of Things and so on. I could talk about that a long time, but I won't. But those are what I'm using here, just programmed to turn them into beacons. Arduino, who knows what an Arduino is? More of you know about that, and everyone knows what a Raspberry Pi is, I would think. Again, you can turn those into Bluetooth beacons, no problem. Pi 3 has Bluetooth on board, Pi 2 you need a dongle. Okay, so all these things can be turned into Bluetooth devices. That's code up there, by the way. So the BBC microbit you can program in C++ if you want to, which tends to be what I do, but if you're an 11-year-old and you've never programmed before, you can use that tool from Microsoft, and that is all the code to turn your microbit into a URL Eddystone beacon. Very, very simple. So I personally wouldn't buy one. I'd program something to turn it into a beacon. And you can probably use your phone, or you may be able to. I'll show you here something I've knocked up. So from Android 5 onwards, APIs appeared that allowed phones to advertise, and more than that actually. The APIs became way more powerful. But you have to have the right hardware underneath as well. So I have a Nexus 5 at home, well actually over there, which has Android 7 on it, so it's got the APIs, but the hardware doesn't let it advertise. But I've got a Nexus 9 just there, which same Android version does have the hardware, so it can advertise. And I've got a Pixel on stage here, which also is more modern and can do both. So I'll show you this thing. Yeah, this could be a little confusing actually, but anyway. And so I'll just get rid of my slides, that might help. And you'll know what you're looking at. Okay, let's just try this. So there's an application. If I hit start, it says start advertising. And if I try and drive the tablet over here, which is still popping up beacon notifications, just get rid of that. I'm just going to fire up a free application from Nordic Semiconductor, who make Bluetooth chips and stuff. Hang on. This is a really well prepared demo, as you can see. So somewhere on this list is listing all the devices it can see. And here we've got one that says physical web next to it. I can see where I'm pointing. You might struggle to see where I'm pointing from back there. But the one that says physical web is my phone acting as a beacon, and it's advertising a URL of one of my websites. If I hit the open button, fires up the browser and takes me to that website. So that was an Android smartphone being a portable mobile beacon. So you have APIs that let you do that, which is very nice. Let's stop advertising now. Resume. Come on, PowerPoint. Very good. So you can do it with Android. Do the whole thing with Android. Keep it in-house. So here's some code. I'm going to try and zoom in on this, try and make this a little easier to read. So this time, sorry, I'll work my mouse basically. So this time the key class is called Bluetooth LE Advertiser. So we use Bluetooth LE Scanner for scanning. Bluetooth LE Advertiser, not surprisingly, lets us advertise from our device. And we have some advertise settings and a builder that lets us configure advertising settings, and advertise data, which is where we decide what data we're going to actually advertise. And if we go to the next slide, you may or may not see what that looks like. There's an if statement at the top that says if is multiple advertisement, I can't say it's supported. This is asking about the hardware capabilities of the device. I'm pretty sure that returns false if your device can't do the advertising at all. Okay, so that's a handy thing to have in there. And then if you look further down, you can see I'm using the advertising settings builder to make some statements, again, kind of about power and how I'm going to use it. So some things kind of hard-coded into Android with some nice, easy-to-use constants being used there. And I'll just do that. Go to the next slide. Zoom in again. So here I'm using the advertising data builder, and I'm saying I want the device name in my advertising packet, and I want the Eddystone service UUID and some associated data, and that data contains a URL. And then at the very near the bottom there, I'm saying advertiser.start advertising. So similar pattern, some configuration to do, some settings to apply, and then I say start, and now I'm advertising, and you saw the rest. I'm assuming at some point someone's going to kick me off stage if I'm massively overrunning. I'm nearly done actually. So, what's happening next? I've essentially been describing Bluetooth version 4, which is almost certainly what your phones have in them. You've probably got 4.1, or if you're lucky 4.2, unless you've got a very old phone. Just before the end of last year, December, we released Bluetooth version 5. When I say release, that means there's a new version of the spec, because we don't make anything. We say, here you go, manufacturers, do this. And Bluetooth version 5 had a number of fairly phenomenal changes. It's a big step change, actually. That's why I got even a whole new integer value. First of all, the range is 4 times more than it was. And the Nexus 5, that's over there somewhere, I've measured it with a range of 392 meters against one of these little things. So Bluetooth has a way bigger range than people realise these days. Anyway, and that's Bluetooth version 4, so nearly 400 meters. And there are commercial Bluetooth modules, they're called, on the market that claim a range of 500 meters. And I have no reason to disbelieve them given my own testing. So Bluetooth version 5 gives us quadruple that range. So we're over 1 kilometre now. So start thinking about smart city applications. Never mind smart building. There's definitely some smart city applications. Suddenly it becomes a good technology for. It can go twice as fast as well. And by the way, you can choose what range you want. It's all configurable, and there will be APIs, I'm sure, that let you get to this stuff. Twice as fast, that's 2 megabits per second, which is slow in terms of gigabit Ethernet, but very fast in terms of the low-power wireless communications technology. Comparable low-power wireless technologies have limits of 250 kbits per second. So 2 megabits per second is way faster than comparable technologies. But the one that matters for this talk, which, if you recall, and are still awake, is about beacons. You're still awake, I can tell. Is that those tiny packets that I talked about earlier on, 37 bytes total, 31 available for you to put your payload in, those length type value things, becomes 255. Furthermore, we do some clever things in the way that we use the radio spectrum as well. Radio channels matter, okay? Physics, it's finite. The more wireless devices there are in an environment, the more chance there is of congestion and of things not working. So be really clever with how you use radio resources. Bluetooth does something called frequency hopping. It doesn't just stick on one channel like Wi-Fi once you've picked it. It hops around 40 different channels. And we've done some stuff there around advertising as well, so that it scales even more. So you can have thousands of devices all in one place. For the purposes of today, though, just focus on the capacity thing. Suddenly beacons can say a lot more about themselves because packets can be bigger. But if that's not enough for you, you can split your data, because you want to say an awful lot about this industrial machine and all its different measurements. You can split it into multiple packets and chain them together. So suddenly, we're into what I think will become second generation beacons. Instead of saying one thing about a place or an object, now that thing can have a very rich description about itself broadcast to the world. All sorts of interesting applications there. So I'm going to close, I think this is closing. Yeah, more or less going to close with just some comments about this. And again, session to go to tomorrow, I'm not going to be here, otherwise I'd go to this one. So I think it's reasonable to say that Apple kind of kicked off the beacon idea with iBeacon, but Google have absolutely, without question, picked up the ball. And on the one hand, they have the physical web project, which is all about making things in the environment easy to walk up and use. Walk up and use anything is their tagline. It's all based around Bluetooth beacons, largely anyway. The thing I love about it is it's really ambitious. They're not thinking small, they're thinking really, really big. It's becoming a cloud-based service. It's becoming an integral part of the Android operating system. So again, this is the significance of beacons for the Android developer community. There's also Web Bluetooth, which is a JavaScript API which is in Chrome now on various platforms, going through various W3C processes such that hopefully it'll go cross-browser, and then it'll end up being the de facto way that web developers work with the physical world, straight from the browser. It works today, it's just not cross-browser yet. And last but not least, there's the Nearby project as well. And we have the honour to have the lead from that team in the audience today. I won't embarrass him by pointing him out. Oops, there I did it. Which also is a really interesting project, which is all about people, things, proximity, and so on. Very cool. So kudos to Google for all they're doing there. So my friends, that is the end of my little talk, my humble little talk about Bluetooth beacons and the world of proximity. Major change going on. Hope you found that interesting. Thank you very much for listening. Oh, one more thing. This is why you're here, isn't it? I can tell. There is a prize. So these things are absolutely amazing, and they're going global. Okay, it's been a UK thing so far. They're appearing in all sorts of other countries now. They'll be available in the US soon. Happy to know they're going to get all over China soon as well. Very much about the education environment, but very much a really cool device to play with. There, I said it. BBC microphone. So I have one to give away, and to win it, you need to follow me on Twitter. There's my Twitter handle, Bluetooth_MDW. No impolite guesses about what the D stands for, unless it's funny, in which case I might be okay with that. And the best tweet will win, where best is very ill-defined. The one I like best. So I'll just tweet you back and say, yeah, come get your BBC microphone. Thank you very much for listening. I suspect I've got 2 minutes for a question.
Yeah,
3 minutes for a question. Okay, so some short questions, please.